Hello there, welcome to our mathematics lesson today. Previously we introduced the pi and circumference, and we just want to move ahead by looking at the arc length and the perimeter of sectors and composite figures. So when we are talking about an arc, when we were looking at the circumference of a circle, we simply said that an arc is part of the circumference of a circle. So when we are having a circle, then part of that circle is what we are referring to as an arc. So if this is the circle I have, then out of the circle, I take part of the circumference of that given circle. Then whatever that has been formed is an arc. So this part of the circumference is what we are calling an arc. So this is an arc of that given circle. So we said that the portion that is surrounded by an arc together with the two radii is referred to as a sector. So we have an arc and a sector. A sector is simply that portion that is being surrounded by the arc together with the two radii. You discover that when this arc is taken out of the circle, there is an angle that is subtended at the center of the circle. So this is the angle that is subtended at the center of that given circle. So earlier on, we looked at circumference of a circle, and we said that circumference of a circle is simply obtained by pi d or 2 pi r. So we have the two options depending with, are you working with the diameter or the radius? So when you're working with the diameter, then we know that the circumference is given by pi d. When you are working with radius, then our circumference will be obtained by 2 pi r. But we are now talking about the arc. We need to get the length of this given arc. We are not talking about the circumference of the whole circle, but part of the circumference of this given circle. So how do we get the length of the arc? The length of the arc then will be obtained by the angle subtended at the center of the circle divided by 360 multiplied by pi d. Angle that will be subtended at the center of the circle over 360 times pi d, or we are talking about the angle subtended at the center of the circle multiplied by 2 pi r. So this is what we are talking about, where L is representing the length of the arc, and theta is representing the angle subtended. So theta is representing the angle that is subtended at the center of the circle, and L is representing the length of the arc. So when we are asked to obtain the length of the arc, then we are still looking at the same formula that we had for the circumference of the circle, but what simply happens is we add in the fraction of the circle that has been portioned. So in this case, the fraction of the circle will be obtained by theta over 360. So this gives us the fraction of this given portion of the circle that will be made. So we are saying that length of the arc is given by theta over 360 multiplied by pi d, or theta over 360 multiplied by 2 pi r. That is how we obtain the length of the arc. But supposing we've been asked to get the perimeter of the sector. So perimeter of a sector perimeter of that given sector will be obtained by, first you need to get the length of the given arc, because we are talking about a sector of a circle. This is what we mean, that we are having that sector of a circle, and we need to get the perimeter of that given sector. We simply said that perimeter is the distance round the given figure. So if I'm getting the perimeter of this given sector of the circle, then it means I need to know the length of this given arc. Then after getting the length of the arc, we shall add the value of the two radii. So that means perimeter of a sector will be obtained by theta over 360 times pi d, then plus 2r. Or alternatively, we are having theta over 360 times 2 pi r, then plus 2r. So those are the options that we have when we are calculating the length of the arc, and this is the perimeter of the sector. So we need to understand first, what are we required to find in the given question? Are we finding length of the arc, or are we finding the perimeter of the given arc, of the sector, I mean? So we have a question that is just going to help us find out how do we get the rule when we are calculating the length of the given arc. We've first started by saying that the length of the arc will be obtained by theta over 360 times pi d, but that theta over 360, we said that it is simply showing the fraction that is being represented by the given sector of the circle. So looking at this question, let us just find out what is the fraction that is being represented by various angles that will be subtended at the center of the circle by an arc. So the first one we have an angle of 180 degrees. We need to know what fraction of the circle is being represented by 180 degrees. This will be 180 divided by 360. So that 180 divided by 360 gives us a half. So what is the rule that will help us get the length of the arc in this given angle? Then it means we have a half times pi d. What is the diagram that is representing whatever we've just talked about? We are simply having a semicircle. So we have a semicircle to show the 180 degrees. So that is the sector of the circle that is giving us 180 degrees. The other angle we have is 90 degrees. So we need to know what fraction of the circle is represented by 90 degrees. This gives us 90 divided by 360 degrees, and 90 divided by 360 gives us 1/4. So an arc length will be obtained by 1/4 multiplied by pi d. So the fraction that is representing 90 degrees in that case is 1/4. So our arc length will be obtained by 1/4 times pi d. So the diagram that is representing the details we have here, we are having a quarter of the circle. So that means a quarter of the circle So a circle that is showing an arc that subtends 90 degrees at the center of that given circle. Another angle we can try and find out, we have 45 degrees. So we need to find out what fraction does 45 degrees represent. That is 45 out of 360. So this will mean that 45 into 360, we can try and simplify. 9 into 45, we have 5, and 9 into 36, we have 40. Then 5 into 5, 1, 5 into 40, 8. So that means that 45 over 360 simply represents 1/8 of a circle. So the formula that will be used, we are having 1/8 multiplied by pi d. So 1/8 times pi d will give us the length of that given arc. So what is the diagram? We need to show an eighth of a circle. So this means that if I have this given circle, then I need to have an eighth of a circle. Those are just quarters to that circle. So I'm looking for an eighth of the circle. So one of the portions of those that we've come up with will represent whatever we are talking about. So that is the eighth of the circle that we have, and you're saying that this one is subtending 45 degrees of 45 degrees at the center of that given circle. So that is just one way of trying to find out how do we go about the length of the arc of a given circle. With this question, I believe we can now go ahead and solve some of the questions that are asking us, or where we are being required to find the length of the given arcs. So we are required to find the length of the following arcs for the given angles. So we have the arcs and the given angles, and we need to get their length. So how do we get the length? The first one we have We have an arc that subtends an angle of 60 degrees at the center of the circle. The radius of that given circle is 8 centimeters, and we need to get the length of the arc. So how do we get length of arc? The length of the arc is given by theta over 360 multiplied by 2 pi r. Theta over 360 times 2 pi r. So we are having our theta is 60 divided by 360 times 2 times pi multiplied by 8, because our radius is 8 centimeters. From there we can simplify. 60 into 60 once into 360, we have 6. 2 into 2 once, 2 into 6, 3. So we are left with 8 pi divided by 3. So we need to get the value of that to 2 decimal places. So we have, when we simplify, we have 8.38 centimeters as the length of this given arc. Part B. We have an arc that subtends an angle of 80 degrees. Its length is, the length of the radius is 4 meters. We need to calculate the length of this given arc. So length of the arc is given by theta over 360 times 2 pi r. So this means that our theta is 80 divided by 360 multiplied by 2 times pi times our radius, which is 4 meters. So when we simplify, then that means that 8 into 8 once, no, 4 into 8, 2, 4 into 36, we have 9. So we have 2 times 2 times pi times 4, then divided by 9. What is the value of that given answer? We can just press on our calculators and get the required figure. So when we work it out, we get that our length of the arc is 5.59 meters. Remember, we are giving our answer correct to 2 decimal places. So we need to consider the number of decimal places in our answer. So we have another arc that is subtending an angle of 300 degrees at the center of the circle, and we need to calculate the length of that given arc. So that means our length of the arc is obtained by theta over 360 times 2 pi r. So that means that we have 300 over 360 times 2 times pi. Our r is 26. So in that case, if we try and simplify, then we have the 0 and 0 will cancel out. 2 into 2 once, 2 into 36 is 18. 2 into 18, 9. 2 into 30, we have 15. Then 3 into 15, 5. 3 into 9, we have 3. So we are left with 5 times pi times 26 divided by 3. 5 times pi times 26 divided by 3. When we simplify from our calculators, we get that from our calculators we have 136.14 centimeters as the length of our given arc. So in this case, the sums that we've just worked out, we've only been finding the length of the arc. But let us look at a situation whereby we are required to get the perimeter of the sector that will be formed by the portion that will be surrounded, the sector that is the portion that is surrounded by the arc together with the two radii. So if we are required to get the perimeter, how do we go about it? Let us just look at an example that is dealing with whatever we are talking about. So we are required to find the perimeter of the sectors that we are going to draw correct to 1 decimal place. So the first sector we have is a sector that is subtending an angle of 90 degrees, an arc that is subtending an angle of 90 degrees at the center of the circle. So this is what the sector that has been formed out of that circle. So we need to get the perimeter of this given sector. We simply said that perimeter is the distance round the given figure. So this is a radius of a circle, meaning this side and the other side are equal. So if this is 4 centimeter, this one is also 4 centimeters because they are radii. Then from this point to this point, then this is our length of the arc. So what are we required to do for us to be able to get the perimeter of this given figure? Then it means we need to find out what is the value of our length of the arc. So how do we get length of the arc? Length of the arc is given by theta over 360 times 2 pi r. Theta over 360 times 2 pi r. But you are not interested with the length of the arc only. We need to get the perimeter of the sector. So that means to get the perimeter of this given sector, then we have theta over 360 plus, times 2 pi r, then plus the 2 radii that we have. So if we are getting the perimeter, then it means we will have to add the 2 radii, so plus 2r. So in solving this, our angle at the center is 90. So that means we have 90 over 360 times 2 times pi. Our radius is 4. Then plus 2 times 4. So this means we are solving whatever is on this end first before adding. So this will mean that this is 90 into 91 into 364. Then the 4 and 4 will cancel out so that we are having so that we have 2 times pi, then plus 8. 2 times pi plus 8. Remember, we are giving our answer correct to 1 decimal place. So 2 times pi which gives us 14.3 centimeters as the required answer. So 14.3 centimeters is the perimeter of our sector. The second example we have a sector that has 115 degrees at the center. So that means calculating the perimeter of this given sector will be obtained by theta over 360 times 2 pi r plus 2r. So our theta is 115 over 360 times 2 times pi times our radius, which is 3.5, then plus two times 3.5. So 2 times 3.5 gives us 7. Then we have 115 over 360. We need to find out that fraction. So simplifying our expression, then it means whatever we have, 5 into 10 is 2, 5 into 15, 3. 5 into 36, we have 7. 5 into 10, we have 2. Then 2 into 2 once. 2 into, so the fraction that is being represented here is 23 out of 72, but we can still simplify this so that we have 36. 2 into 72, that is 36. So we are left with 23. Times pi times 3.5 divided by 36. So when we simplify that and add 7 from our calculators, what do we obtain? So we find that we have 14 centimeters as the required answer. So when you're having a sector or an arc that subtends an angle of 115 at the center of the circle and the radius of that given circle is 3.5, then the perimeter of the sector that is formed by that arc and the radius will be 14.0 centimeters. 14.0 centimeters. Our answer was to be given to 1 decimal place. So that is why we are having 14.0 centimeters. So we've looked at perimeter of given sectors. Let us look at a place whereby we have composite figures. So we have a figure that is made up of a diagram that is made up of different shapes, and we need to get the perimeter of that given diagram or that given figure. How do we go about it? So we can look at that example. We can look at the solution to the given problem by solving the following question. So it is important to note that we said earlier that when you're having sides that have the same symbol, then it shows that those sides are equal. So whatever we are having here, this means that this side is equal to the other side, and so far this one is equal to that, which is also equal to the other side. So this means that we are having a rectangle together with a sector of a circle. So we need to get the perimeter of this composite figure. How do we go about it? I know some of us might be thinking that now that we have a rectangle and we said that the perimeter of a rectangle is obtained by 2 into length plus width or breadth, a person might be thinking of working out using that formula. But what are we talking about? We said that perimeter is simply the distance around the figure. So we are having distance around the figure. So this means that if I'm starting at this point, I'm supposed to go round the given figure. So what does that mean? There is a point on this figure, this line in between, that we are not going to include it in our calculation. So this means that we are supposed to get this distance. If I'm starting from this point, then I'm getting that distance plus this distance plus this distance plus this one. Then this is an arc. So it means we have to get the length of this given arc. Then we add it on our value that we've obtained. So this means that to get the perimeter of this given figure, we have 4 plus 3 plus 4 plus 3, because we are saying that this length and this one are equal. So this is 3 meters. This one will also be 3 meters because they are equal. So I have 4 plus 3 plus 4 plus 3. Then I need to get the length of the arc. So how do we get the length of the arc? Length of the arc we are saying is theta over 360 times 2 pi r. So this means that if I try and simplify this, I have 4 plus 3, which is 7. 7 plus 4 gives us 11. 11 plus 3 is 14. So we have 14 plus the length of this given arc. So this is 90 degrees that has been subtended at the center of our circle. So it means we have we have 90 over 360 times 2 times pi times 3, which is our radius in that case. So our radius is 3 meters. So in that case, we simplify whatever expression we have. So that 90 into 91, 90 into 364. So we have 2 into 2 once, 2 into 4, 2. So that we are left with 3 times pi divided by 2. Remember, we have a 14 to add to whatever we have. So when we simplify 3 times pi divided by 2, what do we get? So 3 times pi divided by 2 gives us 4.7. So it is to 1 decimal place. That is why we are having 4.7. So when we add 14 plus 4.7, then we obtain 18.7 meters. So our units are meters, because whatever measurements we've been given on our diagram are in meters. So that means the perimeter of this given figure that we have is 18.7 meters. So we have this figure that we need to get its perimeter. So getting the perimeter of this figure, then it means we have an arc that has been formed by this circle. So this is the arc of the circle that has been formed. So we need to get the length of this given arc. Then in addition to the length of the arc, we have the two sides that are indicated. So the angle that is subtended by that arc at the center, this is 90 degrees. So this means that this is 270 degrees. So length of the arc is theta over 360 times 2 pi r. So that means we are having 270 over 360 times 2 times pi times 10 millimeters. So this will give us the length of that given arc. But what we are looking for is the perimeter of the figure. So how do we get the perimeter of this given figure? We've already gotten the length of the arc, and we want to get the perimeter. So this means that we are told by these lines, it simply shows that these four sides are equal. And if this is 10 millimeters, then we are having 10 millimeters. We have another 10 millimeters, and this one is also 10 millimeters. So from there, getting the perimeter of that given figure then will be 270 270 over 360 times 2 times pi times 10, which is the radius of the given arc, the given sector, plus 10 plus 10. The two 10 are given by these sides. So we have the two sides that are giving us the 10 millimeters. So from there, we try and simplify and find the values of our required value in our calculation, so that the 0 and 0 cancels out. We are having 9 into 27, 3, 9 into 36, 4, then 2 into 2, 1, 2 into 4, 2. We have 2 into 2, 1, 2 into 10, 5. So we are left with 3 times pi times 5. So let us find out 3 times pi times 5. What is the value? So 3 times pi times 5 gives us 40.7, then plus 20, which gives us 40.7 plus 20 gives us 60.7 millimeters. 3 times pi times 5 is supposed to be 47.1, so that we have 67.1 millimeters as our perimeter. So the perimeter of this figure that we have is then 67.1 millimeters. So the other shape we have a square at the center. Then this square is surrounded by the semicircles, and we need to get the perimeter of this given figure. So for us to get the perimeter of this figure, then it simply means that we are interested with the distance around the outside of the figure. So we are looking for the around the outside the given figure. So this means that if I'm starting at this point, then I'm going round to that point, I'm moving to the other end, move to this point, and finally come back to the starting point. So what does it mean? We are simply getting the length of our arcs. And since we have these symbols, the same symbols, it indicates that these four sides are equal. So if this is 4 centimeters, then this side is also 4 centimeters. This will be 4 centimeters, and this will be 4 centimeters. Then I need to get the length of the arc. So if I just pick one of the arc, because they are all equal, so I can just use one of them, then multiply by 4, because they are 4 in total. So we have length of the arc is obtained by theta over 360 times pi d. So our theta, this is a semicircle, so the theta is 180, which just represents a half of the circle. So we have a half times pi, and our diameter is 4 centimeters, but we are having a total of 4 of these semicircles. So we have a total of 4, so this means the value I obtain here, we multiply by 4. So if you try and simplify, then 2 into 2 once, 2 into 4, 2. So that we are left with 2 pi times 4. So 2 pi times 4, let us find out from our calculators, what do we obtain? 2 pi times 4. We get that 2 pi times 4 gives us 25.1 centimeters. So that means that the perimeter of this given figure to one decimal place will be 25.1 centimeters. So there are situations whereby you can be given the length of the arc, you are given the radius of the sector of the given circle, then whatever you are required to find is the angle that is subtended by the given arc. So let us look at a situation whereby we need to calculate the value of the angle that is subtended by the arc at the center of the circle. So we have the diagram with, we've said that not always you'll be required to get the arc length, but there are situations whereby you can be given the length of the arc and you are either required to find either the radius or the angle subtended at the center. Like whatever we are having in this case, we've been given the length of the arc and the angle subtended at the center of our circle, and we are required to find the radius of this given sector of a circle. So how do we get the radius from our calculation? First, just to remind ourselves, the length of the arc is obtained by theta over 360 times 2 pi r, in case we are working with radius. So if length of the arc is given by theta over 360 times 2 pi r, we need to find out what values have we been given, and we discover that we already have the length of the arc and we have theta. Whatever we are missing is the radius. So that means if I try and substitute the values I have in my equation, then it means 4 will be equal to 30 over 360 times 2 times pi times r. So when we simplify, we are left with 4 is equal to pi over 6 times r. 4 is equal to pi over 6 times r, and we need to get the value of r. So for us to get the value of r, we first start by multiplying both sides by 6. So multiply the left hand side by 6, multiply the right hand side by 6, so that we have 4 times 6 gives us 24, will be equal to pi r. Then next we need to get the value of r, so divide by pi, divide by pi, divide by pi. So divide both sides by pi, so that we are getting 24 divided by pi will give us the value of our radius. From our calculators, let us find out what is 24 divided by pi. Divided by pi. Remember, the question requires us to give our answer to 1 decimal place. So 24 divided by pi gives us 7.6 meters. So we have 7.6 meters. So we've been looking at the arc length, the perimeter of sectors, and the perimeter of composite figures. Whatever is important to note is that the arc length is simply obtained by theta over 360 times pi d, or we have theta over 360 times 2 pi r. So that is how we get the arc length. Area of a sector, I mean the perimeter of a sector, then is obtained by the length of the arc, the length of the given arc, keeping in mind that the length of the arc is obtained by theta over 360 times pi d, or theta over 360 times 2 pi r. Then we have perimeter will be obtained by length of arc plus 2r, where r refers to the radius. Then for the composite figures, then we need to find out, we are first saying that a composite figure is a figure that is containing more than one of the basic figure that we know. So when you're having a figure that has more than one diagram, what you need to identify in the diagram is that those shapes that we have, we are covering the distance around the given figure. So if it has various figures, you need to calculate the distance around the various figure. We are not dealing with whatever is inside, but around the outside part of the given figure. Then we will be able to get the perimeter of the composite figure. So with that, we end our lesson at that point. Thank you.